Sampurna, good. Okay, we'll see Git today. You're getting NDI? Well, okay. Okay, we'll be working on Git today. The Git repository, or Git page on our repository has all the. Let's go to our repository on GitHub. In Git GitHub directory, we have one for workshop. This is going to be a workshop task. But before we move on to workshop, these are the things that we're going to discuss. All right? Before we get into technicalities, let's try to understand what Git is. And try to understand Git in a non-technical sense. Git is not necessarily a technology tool. It can be used by regular people also. Right? Let's see what it is. We take a context and try to understand it. Let's say you're writing something, a story. Right? You're a story writer, or let's say you're writing a love letter. That makes sense. Right? What's your regular process? How would you write a love letter? You written love letters, right? You did not give them, but you did write. All right? So, how do you write a love letter? We're not interested in the content of the love letter, but the process. Okay? You take a paper pen, right? Wonderful. You start with your first line, my dear so and so. Then you scratch it. That's draft one. It did not come out well. So you took a nice paper, another one, probably another pen also. Then you started writing. Let's say you went on for a couple of lines by this time, right? Then you didn't like it. No, this is also not good. So again, so like this, you went on for about 10 papers. 10 sheets are lying over there, right? All folded over like that. Now, while you are writing the 11th draft, you realize the 6th or 5th one was better. What would you do now? All the 10 are lying down there. You want 5th or 6th. You don't remember which one it is. All right? So you want to grab the 5th or 6th one. So what would you do now? How can you grab 5th or 6th? You have to browse through all those thrown out papers, right? Open up everything and see which one is the 5th or 6th one that you are not liking. So what you have done is you have created version 1, version 2, version 3, version 4, version 5 up to version 11 of your love letter. All right? Now then you decided, okay, today I'm not in good mood. I'll write it tomorrow morning. All right? So you put all those papers in a nice stack and put it over there. You went out. All right? Tomorrow you came back, you started writing it. Like this, let's say it went on for a week. You still are not able to really do anything. Then you decided, okay, I'm not able to write it. Let me ask my friend. Maybe he can help. Then you take the bundle, you go to that person, your friend. He looks at all that screen and makes some corrections. How many versions of your love letter you have now after a week? Probably 20, 30. Let's say while traveling back to your room, you missed a couple of those sheets, which were actually made corrections. Now you have a big problem. You were not able to write your love letter. You took somebody's help. He made the corrections. You lost the corrections. So you're not able to do anything at all now. Now, during this process, what we are trying to understand is any creation process requires versioning. It can be a simple book writing or a love letter writing, or when you are creating anything, you are creating a laptop, you are creating anything. So, because creation involves gradual improvements. You create something, you scratch it, you recreate it, scratch it, recreate it, scratch it, recreate it. So, you always have version 1, version 2, version 3, version 4, version 5. Like this, even when you're working alone, you don't need anybody else for the version. Now compare it with a regular, let's say you're writing it instead of papers, you're writing it in a Word document, the same love letter. How would you do that? Today you written a letter, so my love letter -1 dot doc. Tomorrow you have another one. Will you open the same one and make edits, or you will open a new one? Probably you will open the same one, make edits. Let's say you've done it over 7 days. Every day you are opening the same document, you are making edits, which means you are removing what you don't want and you are introducing a new line. On 7th day, you realize I want 3rd day's content. Can you get it in a Word document? No. Word document does not show or does not save anything. It only saves the latest. Then you realize the problem. Oh, this is a problem. So what I'll do is every day I'll open a new file. That's what you decide. So my love letter -day1 dot doc, my love letter -day2 doc 2 doc, my love letter -day3 dot doc. So you have 10 documents. Each document probably has almost same content with minor variations. Now you are happy. You can bring out anything you want at any point of time. That's also version. Now let's say take it to the next level. Let's say 3 of you or 4 of your friends. All of you are together writing a story. Right? Each one of you is sitting at your home and you are writing your one chapter of a story. I said there are 4 chapters in that story, novel. All right. Each one decided to write one chapter. So you written your story, that person is writing his story, third person is writing third person's story, fourth person is writing fourth person's. Let's say after a week, you want to club them. Now when you want to club it, obviously you need to send it to everybody else because that's how the whole story comes up. If there are 4 writers, how many people you have to send it to? Let's say you are writer 1. You send it to 3 people. So you also get versions from other one, right? So how many files you get? From 3. Right? So you have 4 files now. Each other person also has 4 files. Let's say everybody made edits to everybody else. You got 3 right from others. You made some changes. Spelling mistakes, sentence corrections, rewriting the sentence in a better way to suit your chapter. So how many edits you made? 3 other files you made edits. Obviously you have to send it to them. How many files they have now? Probably 10, 20. Now if the numbers are more or if the edits are more, you have more number of files. Now if you have large number of files, you have serious problem tracking things. So anything when you are doing it alone or when there are multiple people involved in creation process, version control or version tracking is common. Isn't it? You are writing a story, you are writing a love letter, anything. Now the same thing applies to software code also. In a normal software code writing, there are about 10, 20, 30 developers writing their own components. All those things should work together as a software piece, isn't it? Now when 10, 20 people are writing, the same problem they come across. They write the code, it goes for a review, there's another copy, the same person makes the edits, there's another copy, there's another copy. Now with a book, if you have problem, it's okay. It's a simple problem. But with the software, if you can't track it, obviously you can't create a good software. So version control is really, really important when you want to create software quickly. That's when the version control systems have evolved, usually called SVMs. Software version control, some people call it SVC. Nowadays, the most popular version control system is Git. Git is developed by the same person that developed Linux operating system, Linus Torvald, while he was writing Linux operating system in C. Linux is written in C, right? So what Git does is, it basically keeps track of all your versions, V1, V2, V3, V4. That's what Git does. All right. Let's see how Git does. So far, clear? Right? We need version controlling. Why we need version controlling is because we are constantly changing things. Every time we change something, we store it. And we need to keep track of all the changes. So any version control system, what it does, it tracks changes. Anything. That's the keyword of any version control system. Version controlling is nothing but tracking the changes. Git does the same thing. Before Git also, there were a lot of softwares, but nowadays Git seems to be the most popular. All right. So in general, normally developers use it very much, but as we just now discussed, it's not just for developers. If you are writing code, let's say you are writing a bash script, you can use Git to control all the versions of your software. Or you are writing a simple text file, a log or a story, you can use Git. Now Git, let's see how it actually does it. Now we're looking at the architecture of Git. We're only talking about Git now. We did not touch GitHub yet. We will reach there in a moment. These two things come together most of the times. We're only talking about Git for right now. As I said, Git is something that can track your versions. Let's say you created a file on your Linux system, file 1. In this, let's say you said line 1, that's your first line. This is your version 1. You want to store it somewhere, so you tell Git store it. What Git does is, let me change it. So this is your file, file 1, and you have line 1 in it. What Git does is, it creates a directory called .git in the same location where you have your file. All right. Now the way you tell Git is Git init. You're saying initialize a Git format, means start storing the stuff. So when you say Git init in the directory where your file is, it starts to store this file inside this directory. What it basically does is it compresses the file heavily and stores it in this directory. That's it. That's what it does. Very simple stuff. Nothing too complicated. All right? And it gives something like maybe one less. So where your file is now, it's inside the .git directory. Now this one where you're working is usually called working directory. All right? So you have all the files in the working directory. File 1, file 2, file 3, file 4. You have lots of such files. All right? Each file have something that you want. It could be code or it could be a simple text. Remember, Git can only track complete code. Means either it should be text or some kind of programming language. It cannot track other software formatted files, like it cannot track XML, XLS files, or it cannot track PDF files. It cannot track images. They're all other softwares. All that it can track is plain text only. It should be plain text. It could be regular English or it could be some programming language. That's what it can track. If it is an Excel sheet, it does not know how to read Excel sheets because Excel sheets can be read only by MS Office software. Git cannot interact with MS Office software to read these things. So Git does not know what is inside your Excel sheet. The same way, it cannot read PDF without Adobe PDF Reader. It cannot interact. So all that Git can do is track only plain text files only. It has to be regular code. Alright? So what you have here is, you have a list of files, each file containing your data. Now when you say git init, it basically creates the whole structure .git. Then what you have is, let's say you made some changes to F1, F2, F3, everything. Alright. You put all the changes in the next one called index. Index is where you are getting ready to compress these files. Normally what happens is, when you want Git to store the versions, it has to compress everything, make it a archive. That's what it does. Alright? Where that archive gets stored inside the Git. But before you make an archive, there is an intermediate step. Means you're not yet ready whether you want to make an archive or not. You're halfway. Okay, it's something like, let's say you have all the 10 letters. Let's say out of the 10 letters, only 5 you want to store. So you will separate the things that you want to store first. Then you go into the storage. So this index is something when you want to store something. Let's say you want to store F1, F4, F6. You don't want to store F3 and F2 yet. You don't know. Means you are not confirmed that this file is finalized. So what you normally do is, when you are ready to store, you add that file to another tree. It's called index tree, or it's called index area. And the way you do it is git add the file name. So when you said git init, you created the directory structure, and when you wanted to add the file, any specific file, you said git add. Now at this point, the Git software did not compress it. It simply added that, okay, your file is ready for compression. That's what you said. Now, let's say after some time you continued working on this thing. You also added F2 using git add F2. So you have some files here. Now you want all these files, only these files, not these files, to be permanently stored. That's when you do what is called a git commit. This is called the local repository. This, inside this. All these things are working in a regular directory. You have to visualize it like a directory. Let me show it. So I'm opening a Linux session. All right. Let me open a Linux session. All right. We have Git here. Git. I just ran Git command. It shows some inputs. Now I'm going to a directory where Git is tracking the changes. Now let's say ls git repos. This is where all my repos are stored. One of the repos is my k8s repo. Alright. Now if I do ls-la all files, I'll be able to see the .git directory. A is necessary. If you don't give, like yesterday, lr.th, that will not show the dot files. Dot files are like hidden files. You have to use -a to see the files that are starting with dot, right? Just like Windows. Windows has also hidden files. The same way here. This is a slight variation. ls-lrth, you just add a to it. All files you are asking for. So in this case, the .git is where everything is stored. So you can go into .git. This is how it stores everything. We don't have to really worry what is being stored where. That's part of the Git. It will take care of all those stuff. So we are here looking at, now the directory that you are looking at is the local repository. And also somewhere in that directory you are seeing the index. What is the working directory? This one is my working directory. This is where I want to work. All right. So when I want to change some file, you open the file using nano or anything and you change it. Right? So let's quickly do it. I'm going to open another file this time. Let's create another file in /temp mkdir. Let's create a directory d1 cd to d1. If you create a directory, is it a Git repository by default? It is not, unless you initiate it. You have to tell that this is going to be a Git repository. So here, right now, there is nothing. There is no .git because this is not a Git repository. You're going to initiate it using git init. Let's see what happened now. When you did a git init, it initialized an empty Git repository and it created this .git. So this is where this index and the local repository will be stored. So here, ls-la, if you see, that's .git. If you go into .git, you will see the whole directory structure of .git. Some of these directories will have this information. Some other directories will have information that we are committing here. So what is happening here? On a summary high level, you are working on your files in some directory which is initiated as a Git repository using git init. Then you continue your work. When you finalize your work, you try to add it to the index tree or index area using git add. Now once you said, okay, I'm ready, you're ready to compress everything, then you do a git commit. At this point, it compresses everything, makes it into what is called an object. It's called a blob. block object. Block object is a highly compressed file. That's what it is of your versions. So what happened now is when you did a commit, all the files on your index were compressed into an archive, and the archive is stored here. Let's say you keep on doing it. The same files you are editing again and again. After 10 minutes, you did this. Then you did a git add all files. You can say all files by using dot. You can add one file, or you can add all files, or you can add any number of files. Alright? Let's say you are adding all the files. Anything that is on the index, add it. Now once you added, you do a git commit again. So your sequence is like this. You change something, then you do a git add all the files, then you do a git commit, it comes here. So your repository or your local repo has all the blobs in it. So this is blob 1, blob 2, blob 3, that's what, right? Every time you do a commit, you have a blob. So basically, this whole thing is compressed and stored. Just like you have different Word documents, nothing else. Alright? So these blobs, instead of calling them blobs, we call them commits. So you have a list of commits. Whenever you do a commit, it's a compressed blob. These commits are given numbers or IDs. These IDs are very long numbers which are unique usually. So if you see here, I did not do any commit here, right? Let's create a file. Git, how do you create a file? Cat, let's call it file 1, line 1, line 2, line 3, control D. That is done. I created inside .git. I should not. I'm moving F1 to the parent. All right? Yes? So here, okay, I have file 1. In my Git repository, I have file 1. All right? What are the contents of this file? These 3 lines. Now I want to index it, commit it. All right? How do you do that? Git add file 1. That's added. Git commit. When you commit something, you have to give a message. Commit message. All right? -m. Let's say F1 added. That's a message I'm giving. So each commit has a message associated with it to make things easy about understanding the commits. All right? So I did a commit. Now when you commit, usually you should have an email ID and a username. So that username and email ID is associated with the commit. Who is doing the commit? That's what the information is. So I'm going to add that information quickly. Git config user.name. I'm adding any name. Git config user.email anil@info.it.com. This need not exist, it's just information. Alright? Now let's go ahead and commit. Commit -m F1 added. Now that's committed. So one file changed, 3 insertions into that file, create so and so blah blah blah. Alright? Now let's see the commit ID I'm saying. That you see using git log. This is the ID of the commit. That's a very big number, isn't it? These are unique numbers. So every commit is given a unique, very long number. So here you have a big list of commits. So the local repository is basically commit 1, commit 2, commit 3, commit 4, commit 5, like this. Each commit has an information associated with it. It has a number, it has a user who authored it, and also the email of the user and when that commit was made. That's all tracked by Git itself. So what are the commands we have seen so far? Git init to initialize a Git repository, Git add to add files to index, all right? Then Git commit to commit it to the local repository. Along with this, there are some miscellaneous commands: git config user.name, git config user.email. Then we did a git log to see the log file. We can also see git status to see the status of what is these files on index, what are the files in working directory, everything. Let's do a quick git status. Git status. You see, on master branch you are, I'll tell you about the branch in a moment, nothing to commit. Working tree is clean. Basically, we just did a commit. After we did a commit, did we change anything here? Not. Because we did not change anything, Git is saying your working directory is clean. Everything that is in here is already on the repository. Now let's go ahead and modify something here, then do a git status. At that point of time, Git should tell us there is something that has changed here which is not stored yet. Right? So I'm going to change the file f1 now, nano editor f1. You can change it or you can add another line, anything is okay. I'm going to change something just to keep track of version. Version 4, Control S, Control X. Alright. Now we have changed the file. Now let's see if Git is tracking or not. Git status. Right. See this. Changes not staged for commit. Basically what it is telling you is you changed it, but you haven't staged it yet. They are not here yet. And once you want to stage it, obviously you will use your git add or some other command. It's giving that information. Use git add or git restore. What is being modified? F1, which means your git is actually tracking every file in the working directory. If you are making any changes, it tells you that yeah, this file is changed. This is not as it is in the repository. If you want to commit it to the repository, add it to stage or index. Stage or index, they both are same. So you have an index tree or stage tree or stage area. They both are same. Now that you have modified a file, your process is again same. You git add. All right, this time I'm adding all the files. Git commit, -m, f1, new lines added, and then git commit. Okay, sorry, git commit is done. Now if you look at git log, you will have two commits. This is the latest commit. This was the earlier commit. You're basically looking at the local repository, the whole commit tree, isn't it? So this is called a tree. So a local repository is a tree. Now so far, we are working on our system, just like your first scenario where you are writing something for yourself. All right? This is not, you haven't sent it to anybody yet. Now the most important point here is Git can be used on your own system locally. You don't have to send it to anybody. You are using it to track your own stuff. So it's not necessary that you are working in a team, then only you will use Git. If you are working alone also, you still use Git to track everything. And it is also not necessary to write software code only to use Git. You can write a regular English, still use Git to track it. Alright? This can be done on Windows also, not necessarily Unix. If you have Windows, you have Notepad files, not Word documents. It cannot track Word documents. It has to be plain Notepad, alright? Plain text. It can store everything. Alright? So here, we have seen the basic structure. So you have a working directory where you make all your changes, you're working on your code. When you're ready, you squeeze those files, and when you are completely ready to compress and store them, you commit them. So this is a sequence of commands that you normally execute. Git init only once you do it, then normally this is your sequence. Git status, git add, git commit. These are the three commands you keep executing again and again and again. Listen, that's what you do, right? You look at the status, you see if something is tracked or not tracked, you add it to the index, then finally you commit it to the local repository. Now this is called a branch, and usually it's called a main branch. Earlier it was called master branch, but they renamed it to main now. So you have a branch like a tree, the trunk part. That's what you are looking at. That's your master. Now let's say at some point of time, this whole story is not coming as you plan. Alright? Now you want to start everything from scratch, or you want to go in another direction, but you want to keep your original theme. Alright? Let's take a novel kind of thing. Let's say you started writing a romantic thriller first. Alright? It has romance, hero, heroine, all that stuff, and a thriller. Alright? Where there is a suspense, there is a murderer involved. That's a thriller. Now, halfway through it, you thought the thriller is not coming out well. Let me change it to romantic horror. There is a ghost involved now. Alright? But you're not really sure which one is going to come out well. So, halfway through your romantic thriller, you want to keep the same thing, take a copy, then change it slightly into romantic horror. But you're cautious. If the romantic horror does not come out well, you want to be usually able to scrap it and get back to your original one. So basically what you're doing is you're branching out of your main theme. It's just branch. Like a tree, you have a trunk. At some point, a branch comes out. It's still part of the tree. But if you don't want the branch, you can take it off. You still have your main trunk. Now the same concept, let's say you're writing a code. Your main core code is ready. At this point, you wanted to add a new feature. Alright? To add the new features, you want to keep your original files and add the new features. Then what you do is, you branch out of the master branch or main branch. So this is a branch. What happens now is, this whole copy is available, but on a branch. Now you can add another file here to the branch, which is not part of the main branch. So here, let's say you have created a new branch. The way you create a new branch is git checkout. So you're saying git checkout to a new branch -b, let's say new branch 1. This is a command to create a new branch. So now you have created a new branch. That branch is in the working directory also. You added some files, F1, F20, F30, like this. You are on this branch. You are not here anymore. All right. So you are here. Now you made some changes. All right. You added it. Git add dot, which means F10, F20, F30 are added on the new branch here this time. F10, F20, F30. Then you do a git commit. When you do a git commit, they are on your new branch. All right. Now let's say you don't want it anymore. After some time you realize, no, this is not coming well, so let me discard it. At that point, you don't want to disturb your main branch. You only want to remove the branch part. So you do it using git branch delete the branch name -d your new branch 1. Very simple, isn't it? But if you are doing without version controlling, you have to manage all these things. You have to identify which one you want to delete, which one you don't want to delete. That all tracking you should do manually, probably in an Excel sheet or a notepad. Here, what you did is you just branched out, and if you don't like the branch, delete the branch quickly. Or let's say you like the branch. All right, you like the branch. Obviously, you like the branch. Now you want to combine it with your master branch. Then you merge it with master. So you branch out, then you merge it. That is done using, again, you have to go to master branch first. A merge happens, it's like a pulling. So you have to be here. To switch your branches, you always do a checkout. If you give -b, it creates a branch. If you don't give -b, it assumes that your branch is available. At this point, is your main branch available? Yes or no? Your main branch is always available. So you check out into main branch. Now here you are not giving -b. The reason is you are not creating a branch. It already exists. If it already exists, don't give -b. If you want to create a new branch, give -b. So you come here first, and then you do a git merge this branch. What is the branch name? New branch 1. So new branch 1 will be merged into the current branch. So what happens here is all these commits will be merged into the main branch. So all these commits will come here. Now you have a clean main branch. You can delete the branch now using this command. Now we have only one tree. That's clean now. Like this, you can have any number of branches. Let's say developer 1 is, you're working on one, like romantic horror on one branch, then romantic thriller on another branch, then thriller romance on other branch, then horror romance on other branch, horror murder stories on other branch, feel good other branch, factionism other branch, anything, any number of stories you can write. Whenever you want, you merge it, or you just delete it without merging. So your storyline is clean. That way, Git helps you track everything that you are doing. This is used by old developers nowadays. If you are a writer also, you can pretty much use it, but I'm not sure how many writers are software engineers. Some software engineers are writers, probably they use it. Right? You can write short stories, you still use it. Right? So now this is a generic structure of a Git, and all this is happening locally on your system. But usually, just now we said, a lot of people work together in a real world project, right? You are sitting at your home and your laptop, you are writing your code. Your colleague is sitting somewhere else in New York or London. He is sitting at his home and writing his code. You need to exchange this code. How do you do that? Okay. This whole thing is in your local laptop. Windows, Linux, anywhere, it's local laptop. How do you exchange the code?
I think code number.
Code number, but the code has to go there, right? It's in your laptop. So you have to put it somewhere, on a G drive or somewhere. Let's say you put it on a G drive. This whole directory, you tar it, zip it, upload it to G drive. Then he downloads it from the G drive, untars it, unzips it. Isn't that really a bad process? Let's say there are 5 people working. What? Now you are going to have 5 tar? That's the same problem that we had at the beginning. Then we had plain files, now we have tar files. The same headache. So uploading somewhere, you download it is not going to work. That's bad idea, right? So we need some process wherein this whole thing is taken care of. Upload, extract, unextract, whatever. Let the software take care of that stuff. I didn't want to do it manually, isn't it? That's when it comes your GitHub. So right now, let me redraw this thing. You are the one person who is writing the code, and you have your laptop. You have a .git repository with a working directory. What's the next one? Stays or index. Third one, local repository. This whole thing is locally happening on your laptop. Now you want to send it to somebody else. Now the same thing is being done by your colleague also. On his laptop, he has a Git repository with a working directory, index, and local repo tree. This is a main tree, main branch, or somewhere it's called master branch, or lot of branches. Not necessary that there is only always master branch. There are also other branches. Now you won't want to exchange the code. Now obviously we don't want to do a tar, transfer it, download it, extract it mode. You don't want to send your tar to that person. You don't want that person to send you the tar. You hate tar. Alright? Now you found out another mechanism. So there is a software, again, Git, which can take this whole thing and understand this thing, right? Git is the only software that can understand this structure. Yes or no? There are no other software that can understand. So what you can do is, you can take the whole file or whole structure, put it somewhere on the internet, just like G drive. That's what your GitHub is. So what GitHub does is, it's a company, alright, which implements Git. It can take your whole thing, show it the exact same way here. Like you have your repository on a server. So instead of a drive, what you are having, you have the whole Git structure online. So here also, you have working, staging, local kind of thing. You won't see these things because you don't work on the remote server anywhere. You just put your repository over here. So what you have is GitHub, you have a repo. And to this repo, you want to send your local repository. You don't want these two things over there, right? This is yours. But your local repository, you want it on the GitHub. Now this GitHub is called a remote repo. Remote repository. Compare it with local. The local repository is what you have on your system, on your server. Remote repository is where your local repository is replicated. This is done using git push. So you are pushing your local repository to the remote. So here when you say git push remote, you have to give the name, right? This also has, let's say, a master branch or a main branch, branch 1, branch 2, like this, the remote repository. So git push this remote repository, usually called origin. So you are pushing git push to origin. That's a remote repository. On the remote repository, you have to tell which branch. Usually, you push it to main. Or if you want to push it to a branch, you say the branch. So you are saying on that repository, on that branch. Take my this thing. Right? So git push origin, the branch name here main. So what happened now compared to earlier ones? So far here, you are doing a git init, which will initialize everything. Then you do a git add, adds to index. Then you do a git commit, which will commit to the local repository. Then you do a git push, it goes to the remote repository. Now you told your friend, take the code from origin. This guy will do a git pull. Git pull from origin, the main branch. Just like this guy, he can push it. Git push origin main. Now this can be done by any number of people. Somebody else push it, pull it. Now this whole thing is distributed version control, isn't it? It's not on your system anymore. Distributed version control. That's why Git and GitHub together are powerful. Everywhere you are implementing Git structure only. The GitHub provides the distributed part. Multiple people can work together and the code resides in a central repository. Now usually this is where the code is. This is called origin and you have a main branch. Let's say you pulled all your code. This guy pulled everything. Alright? Now while he pulled it, he gets everything right here into F1, F2, F3, all the files. Right? Then he did a git checkout. When you do a git checkout, this whole thing comes here. Let's say he started working on those files. The same file that this guy has worked on. Alright? Then he identified that there are some mistakes. He made corrections to that file. Same file we're talking. Alright? There also we have the same file. Now he made corrections, and what happens? Add it, commit it, push it. Now when you push it, should it directly go to main branch? Do we trust this guy? We don't know. If you made a mistake, probably you also made a mistake. So what happens is, the main branch is usually locked. You cannot push directly to the main branch. Instead, what this guy does is, he pulled everything, right? Pulled everything. Now branch out. Alright? Create a branch. How do we create a branch? Git check out a new branch. Let's say branch 10. On branch 10, you have the same file F1. Alright? You make changes here. Then you add it. You add it to the branch. You push the branch not to the main. Where do you push it? B10. So here you have B10, branch 10. Now that your code is also here, you will ask the main person, the person who is holding the main branch, to merge your code. You have to raise a request for that. Now that request is called a pull request because you are asking your code to be pulled into main branch. So what you are doing, you are making modifications to the cloned code, all right? Then you are committing to your local repository on a separate branch. And this branch you are pushing to the remote repository. And once your branch is available on the repository, you go to the website and you raise a pull request. When you raise a pull request, it will ask you for certain information. What is the branch that you have your code on? Where do you want the code to be merged into? These are the two information. Where is your code? Where do you want it to go? That's it. That's your pull request, very popularly known as a PR. Now, when you raise a PR, the person who owns it or controls it will get a notification. When they get a notification, they review the code of your branch. If that person is satisfied, then they will merge it. After you merged it, your code is here. Now, when you are merging, you have your original file also, right? F1, and also the file that this guy has pushed. The person who is doing the merge will choose out of original versus change what changes need to be kept or retained and what changes need to be discarded. If the person decides it and says, yeah, everything fine, the merge happens and this branch can be deleted. Let's say the person says, no, this is also not correct. The pull request gets rejected. The person rejects the pull request. Now, this is done manually. So, you have a team lead who has the ID which can log into GitHub and locks the main branch. All the developers will create their own branches. They keep pushing their code and they raise PRs. So your main source code is always controlled. It's not randomly somebody pushing code into the main repository. Every code comes through an approved PR. If there is a buggy code in main repository, who is responsible? The person who approved the PR. Now, this is usually done by your team lead or other software engineers. This process is called code review. All right, that's it. That's all it is. And that's all you need to know. I'm going to summarize all the commands. And probably that's what you will need ever. I'm going to write down the commands and that's what you have to remember forever. So to initialize a Git repository, you have git init. Once you initialized, you add your name and your email. So config user dot name, username, git config user dot email. I'm not writing the full command, I'm just giving you the outline of the command. The exact syntax will be in your workshop. Now once you have your initialized and given your details, you start working, then you add to the index. After you're adding, you do a git commit with a message always. Once you have committed, everything is in local repository. You want to change something or you want to branch out, git checkout. If you want a new branch, -b. If you don't want a new branch, directly the branch name. Once that is done, you can add a remote. Obviously, you are saying a remote, right? So git remote add URL of remote repository. You have to tell the local repository about the remote repository. So you are adding a remote repository. So git remote add, here you have origin. You are giving a name to the URL, right? So when you refer to origin, you are basically referring to the URL. Like this, you can add any number of remote repositories. Git remote add, let's say remote 1, that is URL 1. Origin is a general name used by everybody commonly, but it's not necessary that you are only pushing to origin always. Instead of calling it origin, you can call it remote 1 or anything you want. Then once you have the remotes, git push. Where do you want to send it? You can send it to origin or main. Sorry, origin or remote 1, wherever you want. Origin or remote 1. Any remote repository. And on that repository, the branch, the main branch or another branch, any branch. Now, you want to pull everything from the remote repository. Git pull origin from the branch main. Here, git merge the branch name into current branch. Alright? Then there are a couple of other things. We talked about git status at any point of time. It will tell you the tracked, untracked, committed, uncommitted files. Then you can see all the local repository using git log. Then, right, so you, after pushing, you raise a PR, pull request. Then you want to delete something, a branch, git branch -d, the branch name. That's all you need about Git. For a user, Git is really simple. How Git handles things internally is a complex topic. Alright, how it tracks things. If you want to create a Git-like software, it's difficult. For a regular user, it's easy, like a Windows operating system. For a user, it's really easy. But if you want to create a Windows-like operating system, it's really difficult. Alright? So all the difficulty part, it takes away. It's called abstraction. It abstracts the difficulty and gives you a very simple method to keep track of all the things, especially in a distributed environment. So what normally happens in a real world project is all developers are working from their own laptops, anywhere. They write their code. First they pull it from the remote repository, alright, then they start modifying existing one or they start adding new ones. Now this is usually done always on a new branch because nobody has control over the main branch. So every time you pull code, you branch out into something new and you start your work. Once you start your work, this process is same. Status add commit, status add commit, status add commit log, in fact. The status add commit log. These are the 4 commands you keep repeating every day, probably every minute. Now once you are good, probably by evening, you do a git push. And immediately after you do a git push, you also raise a PR. So somebody will review the PR on a day or 2 days. Then either they will approve your PR, in which case your code, your branch gets merged to the main branch, or they reject your PR with comments saying that, okay, this is not correct. Now you get a notification that your PR is rejected and you make your modifications again on your code, add, commit, again push, again raise another PR. Alright? Then eventually at some point of time your PR gets approved and your code gets merged. Now that process for everybody always. So central repository has a source code on the main branch, which is clean. And that code goes to the next stage. You have written your code, right? Now somebody has to test it. You written your code nice, but is it working? You don't know. So far, you just written your code. And all that was done is basic check. Is your code good? Yeah, your team lead has approved it, but the client did not, or nobody knows it's going to work or not. Second thing, nobody knows if all the codes of 10 different developers is going to work together or not. So there are various tests that are done on this code. That is your whole SDLC process. And that's when it starts with your Jenkins, the continuous integration server. So we'll talk about Jenkins later. Right now, we're talking about how the code gets created by a team of developers. All right. Now you don't create the code, right? Why are you learning Git? DevOps engineers don't create the code. Why are we learning Git then? We don't test. Testers test it. You don't develop the application code. There are other types of code that you normally develop. We just now discussed that Git can be used for any type of source control, right? Let's say you're writing a bash script. You write bash scripts, right? You learned in Linux yesterday. All right. Let's say you have 4 or 5 commands. pwd. I think there is a script, right? Date, ls-ltr. You are the one who is writing the script. Now, after a few days, you said, okay, this date command is not coming out properly. Let me change it to date-a or something other. This ls-l-t-r-h-a also you want to add here. So this is version 2. Now, you are not the only one in your team. So there are probably 5 people. So your team lead said, all of you together write the code. Or the person who wrote the code left. You are writing it now. So you need to pull the code, make the changes, push it again. Obviously, your team lead does not trust you. You are still learning Linux. So he controls the repo, remote repo, the main branch. He will ask you, okay, pull the code, make the changes, push it, write the PR. So it's not necessary that it's just a software product. Even for a simple bash script, you will be using the whole Git. Now, for a DevOps engineer in a real world project, you will be using Git for bash. For Python, you will be writing a lot of Python scripts. You will be writing a lot of Terraform scripts, Ansible scripts. All right. Then cloud formation tip. These are the 5 types of scripts you will probably write. Any type of version control can be done using Git. So you will also be doing a lot of Git. That's usually the list of commands you ever need for Git. All right. So we have a workshop. Most of these commands are touched upon all those things. You have to remember these commands. Understanding is not sufficient anymore. You have to remember, which means you have to make a conscious effort to remember it, mug up stuff. Or you have to be able to logically deduct everything, whatever you are comfortable with. Right now, I given you everything logical. Probably I don't remember the same sequence. Means if I repeat it again, the same sequence will not come out. But you can at least give it logical. Either you remember the whole concept logically, or you just remember the list of commands. Anything is okay. All right. So let's go ahead with your workshop. Tomorrow we'll be starting Jenkins. Right. Now these concepts or these technologies, we will be covering Git GitHub, Jenkins, Ansible. Jenkins and Nexus will be together. Docker, Kubernetes, AWS. These are the technologies we'll be covering. These two will take most of the time, Kubernetes and AWS. The rest of the commands or rest of the technologies are very simple technologies. They usually take 1 or 2 sessions. That's all. All right. There's nothing much in those technologies, unless somebody wants to stretch it too much. Like today, is it difficult? It's not really difficult, but it can be taught 5 days. Each day, I can take one line and talk about it. It's not necessary. All right. So we'll be going fast wherever necessary, slow down wherever necessary. All right. This, once you write down your running notes or whatever it is, make sure you keep referring to it at least once or twice a day. One is more than enough. All right. That will just cement everything. All right. Any questions? Cool. Let's start the workshop.